close your eyes, and let yourself settle into comfort. Tonight, we're going on a gentle journey through the atmosphere, where the air itself tells stories older than mountains, and clouds drift like thoughts across an endless sky. Let's begin where all weather begins, in the warmth of the sun touching our world. Every single day, the sun evaporates about 1,000 cubic kilometers of water from Earth's oceans. That's roughly 264 trillion gallons, lifted invisibly into the sky. Imagine that, right now, above you, countless tiny water droplets are floating upward, so light and small that 1,000,000 of them together would barely fill a teaspoon. They rise on currents of warm air, patient and unhurried, beginning their slow transformation into the clouds you see drifting overhead. These water droplets don't travel alone. Each one forms around something even tinier, a grain of dust, a crystal of salt from ocean spray, or a microscopic particle of pollen. The atmosphere is full of these gentle travelers, and every cloud you've ever watched is built from billions of these partnerships between water and dust, each droplet clinging to its tiny anchor as they float together through the sky. And here's something wonderfully calming to know: clouds move slowly. What seems like a cloud racing across the sky during a storm is usually traveling only about 30 to 40 miles per hour. Most of the time, on an ordinary day, clouds drift at a walking pace, just 10 to 15 miles per hour. You could almost keep up with them if you tried. They're never in a rush. They simply follow the gentle currents of wind, reshaping themselves endlessly as they go. Now, think about rain. When a raindrop finally falls from its cloud, it doesn't plummet, it drifts downward at only about 7 to 18 miles per hour, depending on its size. Smaller drops fall even more slowly, taking their time on the journey from sky to earth. A single raindrop might take several minutes to reach the ground from a cloud just a mile high, tumbling gently through layers of air, each one a different temperature, each one slowing or guiding it on its way down. And here's something that might surprise you: raindrops aren't shaped like teardrops at all. They're actually round, like tiny spheres, or slightly flattened on the bottom from the air pushing up against them as they fall. The teardrop shape we imagine is just that, imagination. The real raindrops are softer, rounder, more like the bubbles you'd blow on a quiet afternoon. Even the smell of rain has its own secret. That fresh, earthy scent that arrives just before a storm, called petrichor, comes from oils that plants release during dry periods. These oils settle into soil and rocks, waiting patiently. When rain finally comes, it releases these oils into the air, along with a compound called geosmin, produced by soil bacteria. It's the earth itself exhaling, welcoming the water home. So tonight, as you rest, picture yourself as light as a water droplet, rising slowly on warm air, finding your tiny grain of dust to hold on to, drifting at a walking pace across an endless sky, and eventually, gently, peacefully, beginning your slow float back down to earth. Let's drift a little higher now, up into the layers of our atmosphere, where the air grows thinner and the world below becomes a patchwork quilt of blues and greens and browns. The sky has layers, like a cake, each one with its own temperature, its own personality. The layer closest to us, where we live and breathe, is called the troposphere. It extends about 7 miles up at the poles and 12 miles up at the equator. This is where all our weather happens: every snowflake, every breeze, every thunderstorm. And here's something soothing: despite all the weather that swirls through this layer, it contains about 80% of the atmosphere's total mass. We're wrapped in a thick, protective blanket of air. Temperature does something curious as you rise through the troposphere. It drops, slowly and steadily, about 3.5 degrees Fahrenheit for every 1,000 feet you climb. By the time you reach the top of this layer, it's incredibly cold, around -70 degrees Fahrenheit. But the air is so calm up there, so still. The turbulence of weather stays below, in the warmer regions where clouds can form and storms can brew. Now, imagine floating even higher, past the troposphere, into the stratosphere. This is where something magical happens. The temperature stops dropping and starts rising again. Why? Because this is where the ozone layer lives, absorbing the sun's ultraviolet light and converting it to gentle warmth. The ozone molecules work tirelessly, quietly, shielding us from harmful rays while creating a pocket of warmth in the cold heights of the atmosphere. Every day, without fanfare, without rest, they protect us. And here's a thought to help you drift towards sleep. The air around you right now contains molecules that have been part of thousands of different breaths, thousands of different clouds, thousands of different winds throughout history. The oxygen you're breathing in might once have been part of a rainstorm over an ancient forest, or a gentle breeze across a medieval field, or the air inside a cloud above an ocean centuries ago. You're breathing history. You're connected to every sky that's ever existed. Wind itself has its own rhythm, its own patience. On a global scale, winds follow predictable patterns called prevailing winds. Near the equator, the trade winds blow steadily from east to west, day after day, year after year. Sailors have relied on them for thousands of years, dependable, constant, like the heartbeat of the planet. These winds are born from the sun heating the earth unevenly, creating gentle pressure differences that guide the air in its endless circulation around our world. Even on a small scale, wind follows comforting patterns. During the day, land heats up faster than water, creating a sea breeze that flows from ocean to shore. At night, the pattern reverses. The land cools more quickly, and a land breeze flows gently back out to sea. It's the earth breathing in and out, twice a day, every day, a rhythm as old as oceans themselves. So let yourself float here. In this thought, you are part of these ancient patterns, breathing the same air that has circled the globe countless times, held by the same atmospheric layers that have cradled our planet for billions of years, constant, dependable, endlessly patient. Now let's turn our attention to something you've seen countless times but perhaps never fully noticed: the quiet artistry of fog. Fog is simply a cloud that has decided to rest on the ground. It forms when the air near the Earth's surface cools enough that it can no longer hold all its moisture, and tiny water droplets condense, suspended in the air like a soft veil. What's remarkable is just how delicate fog truly is. If you could gather all the water droplets from a cubic meter of thick fog, a space about the size of a large refrigerator, you'd have only about half a gram of water. Less than a single drop. The rest is just air, holding these infinitesimal droplets in a gentle embrace. There are many kinds of fog, each with its own quiet personality. Radiation fog forms on calm, clear nights when the ground releases the warmth it absorbed during the day. The earth exhales heat into the sky, the air cools, and moisture condenses into a blanket of mist that settles over fields and valleys. It often appears in the hours just before dawn, at its thickest when the world is most still, then gradually lifts as the morning sun warms the air once more. It's the earth tucking itself in for the night, then slowly waking again. Valley fog is particularly peaceful to imagine. Cold air, being heavier than warm air, flows downhill like an invisible river in pools and valleys and low-lying areas. There it sits, undisturbed, sometimes for hours, creating those dreamy scenes where mountain peaks rise like islands from a sea of white. The fog doesn't rush. It simply rests in the low places, patient and calm, until the sun grows strong enough to disperse it. Here's something wonderfully soothing. Fog droplets are so small, typically between 10 and 20 micrometers in diameter, that they fall through the air at only about 1 centimeter per second. That's slower than a leaf drifting down in autumn. They're essentially floating, suspended, held aloft by the gentlest movements of air. A fog droplet could take over half an hour to fall just 10 feet, if nothing disturbed it along the way. And consider the silence that fog brings. Sound travels differently through fog because all those tiny water droplets absorb and scatter sound waves. This is why foggy mornings feel hushed, muffled, like the world has been wrapped in cotton. Even loud sounds become softened. Distance becomes harder to judge. Everything slows down, grows quieter, more contemplative. Fog asks us to be still, to move carefully, to listen more closely. There's even something called advection fog, formed when warm, moist air moves slowly over a cooler surface, like when air from over the ocean drifts across cold coastal waters. This fog can persist for days, stable and steady, neither thickening nor thinning, just maintaining its gentle presence. San Francisco's famous fog is often this type, rolling in through the Golden Gate in soft waves, predictable as tides, a daily visitor that blankets the city in its cool, damp tranquility. So picture yourself now, resting in a valley as the evening cools, watching the fog form around you, drop by microscopic drop, each one floating nearly motionless in the still air, the world growing softer, quieter, more distant, sound itself becoming muffled and gentle, everything slowing down, down, down. Let's drift now into the realm of snowflakes, those tiny miracles of geometry that fall so softly from winter skies. Every snowflake begins its life as a simple hexagon, 6 sides, perfectly symmetrical. This happens because of the way water molecules bond together when they freeze. Each molecule connects to others at a precise 120-degree angle, and this creates the natural 6-sided structure. From this simple beginning, something extraordinary unfolds. As the tiny ice crystal falls through the cloud, it encounters different temperatures and different amounts of moisture, and each condition causes it to grow in slightly different ways. Arms sprout from the 6 corners. Branches form on those arms. Smaller branches grow from those branches. And because all 6 arms experience nearly the same conditions at the same time as the crystal tumbles through the air, they grow in synchrony, creating those intricate, symmetrical patterns that seem almost impossible. Here's what makes this even more remarkable. A snowflake might spend an hour or more drifting through a cloud before it finally falls to Earth. During that time, it's constantly growing, constantly changing, responding to every subtle shift in temperature and humidity. The journey through the cloud is like a record of everything that crystal experienced, each tiny variation etched into its structure. 2 snowflakes might start growing right next to each other, but if one drifts even slightly higher or lower during its journey, it will encounter different conditions and grow into a different shape. This is why people say no 2 snowflakes are exactly alike. Each one has taken its own unique path through the sky. Snowflakes fall slowly, so slowly. A small snowflake might descend at only 1 or 2 miles per hour. The larger, fluffier ones, the ones with the most elaborate branches, fall even more slowly because they catch more air resistance. They don't plummet, they flutter and spiral, rocking gently back and forth as they drift downward. On a still winter day, a snowflake might take 20 minutes to fall from a cloud just half a mile high. 20 minutes of gentle floating, turning, catching the light. And snow itself, once it accumulates on the ground, has a special quality. Fresh snow is full of air, sometimes as much as 90 to 95% air. All those intricate branches and hollow spaces between crystals trap air in countless tiny pockets. This is why fresh snow is such an excellent insulator. Animals burrow into it for warmth. The air spaces slow the transfer of heat, creating shelter from the cold. Snow is paradoxically warm in this way, made of ice, yet protecting against winter's chill. There's also a particular kind of quietness that comes with falling snow. Just as fog muffles sound, so does snow, both in the air and on the ground. The crystalline structure absorbs sound waves, dampening echoes, softening noise. A landscape covered in fresh snow becomes extraordinarily peaceful. Footsteps are hushed. Voices carry less far. Even the rustling of wind through trees is gentled. The world becomes wrapped in acoustic stillness, a blanket of quiet as soft as the snow itself. In the far north, there's a phenomenon called diamond dust, tiny ice crystals that form in extremely cold, calm air and drift down from a clear sky like glitter. These crystals are so small, so light, that they seem to float rather than fall, catching the sunlight and creating pillars of light, halos, and other optical phenomena. It's the atmosphere itself sparkling, decorating the air with infinitesimal jewels of ice that descend so slowly they seem almost suspended in time. So let yourself become like a snowflake now, beginning as something simple, drifting slowly through cool air, turning gently, catching the light, taking all the time in the world to make your descent, floating through layer after layer of stillness, settling softly, joining millions of others in perfect, quiet rest. Let's turn our thoughts now to the gentle rhythm of dew, that delicate moisture that appears each morning as if by magic, adorning grass and leaves with thousands of tiny jewels. Dew forms during the quiet hours of night, when the world is still and the earth releases the warmth it held from the day. As surfaces cool, blades of grass, flower petals, spider webs, the air immediately around them cools too. And when that air becomes cool enough, it can no longer hold all of its invisible water vapor. The moisture condenses directly onto these cool surfaces, molecule by molecule, forming perfect little beads of water. Each droplet is a miniature lens, capturing and bending light, which is why a dew-covered lawn in early morning seems to shimmer and glow. What's particularly peaceful about dew is its predictability, its reliability. On clear, calm nights with light winds, dew will almost always form. It requires no drama, no storms, no turbulent weather. Just stillness. Just the patient cooling of the earth. Just the gentle transition from warmth to coolness as night deepens. And then, as quietly as it arrived, dew evaporates with the morning sun, returning its moisture back to the air, completing a small, perfect cycle that happens night after night, season after season. The amount of dew that forms is surprisingly substantial. On an ideal night, a single acre of grass might collect as much as 25 gallons of water from dew alone. For plants in dry climates, this nighttime moisture can be essential, a gentle drink delivered silently while the world sleeps. Some desert plants have evolved to capture and channel dew down their stems to their roots, drawing sustenance from air itself, from moisture that appears only in the coolest, calmest hours. There's a cousin to dew called frost, which forms in much the same way, except when temperatures drop below freezing. Water vapor transforms directly into ice crystals without ever becoming liquid, a process called deposition. Frost creates those intricate, feathery patterns on windows and windshields, delicate crystal structures that branch and spread like tiny ferns. Each frost crystal grows along the microscopic imperfections in glass or metal, following paths invisible to the eye, creating art from nothing but cold air and patient time. Hoarfrost is even more enchanting. It forms when water vapor freezes directly onto cold surfaces like tree branches and fence posts, building up layer after layer of delicate ice crystals. The crystals grow outward, away from the surface, creating fuzzy white coatings that make everything look soft and dreamlike. Unlike hard, slick ice, hoarfrost is fragile, almost weightless. Touch it and it crumbles into powder. It's the visual embodiment of stillness, only forming when the air is calm, when nothing disturbs the slow accumulation of ice. And here's something to carry you deeper into rest. The formation of each dewdrop, each frost crystal, is utterly silent. There's no sound as water vapor becomes liquid, no noise as molecules arrange themselves into ice. These transformations happen in perfect quiet, billions of times each night, across every surface cool enough to receive them. The world is constantly engaged in these small acts of creation, these gentle phase changes from gas to liquid to solid and back again, all happening in a silence so complete it's like the breath of the earth itself, slow, steady, peaceful. Imagine yourself now as a blade of grass in the deep of night, the air around you gradually cooling, moisture gathering on your surface one molecule at a time, feeling the gentle weight of each tiny droplet forming, the world utterly still, utterly quiet, nothing to do but rest and receive, rest and receive. Now let us drift into the world of gentle breezes, those soft movements of air that brush across your skin on a peaceful day. Air is always moving somewhere, but not all movement is the same. The gentlest classification of wind, called a light air on the Beaufort scale, moves at just 1 to 3 miles per hour. This is barely perceptible. You might notice it only in the slight movement of smoke rising from a chimney, drifting lazily to one side. Or in the trembling of a single leaf on an otherwise still tree. This is wind at its most delicate, air moving with such subtlety that it seems almost to be suggesting movement rather than creating it. What causes these gentle breezes is often nothing more than the uneven heating of the earth's surface. One patch of ground warms slightly more than another, perhaps it's darker soil, or a sun-facing slope, or simply a spot where the sunlight lingers a moment longer. The air above this warmer patch expands and rises, so gently that you'd never notice. Cooler air flows in to replace it, moving horizontally along the ground at a pace slower than you walk. This is convection at its most peaceful, the atmosphere stirring itself like honey, slow and smooth and continuous. Here's something wonderful to contemplate, even on what we consider a perfectly calm day, air is never truly still. There are always tiny currents, microscopic eddies, subtle flows too small to feel but perpetually present. Air molecules are in constant motion, vibrating, colliding, moving in random directions at speeds of over 1,000 miles per hour. Yet collectively, in their countless trillions, they create what feels to us like perfect stillness. It's a strange and beautiful thing, this dance of chaos that produces calm. Temperature differences of just a single degree are enough to set air in motion. A meadow cooling slightly faster than the forest beside it. A lake holding its daytime warmth a bit longer than the shore. These tiny imbalances create pressure differences measured in fractions of a percent, and air responds by flowing from higher pressure to lower pressure, always seeking equilibrium, always trying to smooth out the differences. The atmosphere is endlessly balancing itself, adjusting, equalizing, like water finding its level. On a molecular level, wind is simply air molecules moving from a place where they're crowded together to a place where they have more room. High pressure to low pressure. Dense to sparse. The breeze on your face is trillions upon trillions of molecules, each one bouncing off your skin, transferring tiny amounts of energy, creating the sensation of coolness or warmth depending on whether they're taking heat away or bringing it to you. Each breath you take draws in approximately 25 sextillion molecules, that's 25 followed by 21 zeros, and many of those molecules have circled the globe dozens of times, carried on winds gentle and fierce. There's a kind of wind called a katabatic breeze that flows down mountain slopes at night. As the peaks cool, the air around them cools too and becomes denser, heavier. Gravity pulls this cool air downslope in a gentle, steady flow that can continue all night long. It's air draining like water, following the contours of the land, pooling in valleys, completely predictable and utterly calm. People who live in mountain valleys know this evening breeze intimately. It arrives at the same time each clear night, a reliable companion, cool and soft. So settle into this thought now. You are surrounded by air that is always moving, always adjusting, always seeking balance, molecules countless as stars, each one traveling its own tiny path, yet together creating the gentle envelope that surrounds you, protective, constant, asking nothing of you, simply flowing, always flowing, in its own time, at its own pace. Let us float now into the soft world of humidity, that invisible moisture hanging in the air all around you, closer than you might think. The air you're breathing right now contains water, not as droplets you can see, but as individual molecules of water vapor, dispersed evenly throughout the oxygen and nitrogen. On a humid day, up to 4% of the air might be water vapor. That may sound small, but consider this. In a room the size of a typical bedroom, that could mean several cups of water suspended invisibly in the space around you. You're essentially breathing an ocean, molecule by molecule, with every breath. Humidity has a rhythm, a daily pulse. In most places, humidity rises during the night and reaches its peak just before dawn. As temperatures drop, the air's capacity to hold moisture decreases, so the relative humidity climbs even though the actual amount of water in the air hasn't changed. Then, as the sun rises and warms the earth, the air expands and can hold more moisture again, and the relative humidity falls. This happens every single day, a gentle oscillation between more humid and less humid, synchronized with the cycle of darkness and light. There's something deeply calming about the way water moves between earth and sky. A single water molecule might spend about 10 days in the atmosphere before falling as rain. But once it reaches the ground, perhaps landing in a lake or being absorbed by soil, it might stay there for weeks, months, even years before evaporating again. Some water molecules have been cycling through this process for billions of years, rising and falling in an endless dance. The water in your glass tonight might have been part of a cloud over the Sahara last month, part of the Indian Ocean before that, part of a raindrop over the Amazon before that, reaching back and back through an unbroken chain of transformations. Humidity affects how we perceive temperature in such a gentle way. When the air holds more moisture, perspiration evaporates more slowly from your skin, and you feel warmer. When the air is dry, evaporation happens more quickly, creating a cooling sensation. But this happens gradually, subtly. Your body is constantly adjusting, constantly responding to these small changes in the air around you, maintaining your comfort through countless tiny calibrations you never have to think about. Here's a peaceful image. Water vapor in the air doesn't just float randomly. It tends to cluster loosely around certain molecules, dust particles, salt crystals, even other water molecules. These loose associations form and break apart constantly, creating temporary structures that last only moments before dissolving and reforming elsewhere. The air is full of this quiet activity, this endless rearranging of molecules into brief partnerships, all happening at scales far too small to see but present nonetheless, a hidden choreography taking place in every cubic inch of space. In tropical regions, the air sometimes becomes so saturated with moisture that it feels almost thick, almost tangible. The humidity might reach 90 or 95%, meaning the air is holding nearly all the water vapor it possibly can at that temperature. At this point, everything slows down. Evaporation nearly stops. The air feels heavy, still, timeless. There's a particular quality of peace in this, a sense that change itself has paused, that the world is suspended in a moment of perfect saturation, balanced precisely between liquid and vapor, neither one nor the other but somehow both. Let yourself rest in this idea now. You are held in air that is part water, breathing in moisture that has traveled the world, your body effortlessly exchanging heat and water with the atmosphere around you, billions of molecules moving between you and the air in perfect, unconscious balance, nothing for you to do, nothing to control, just this gentle, constant exchange, breath after breath, molecule after molecule. Surrounded by water you cannot see, supported by air you cannot hold, yet both are always there, always present, always enough. Let's turn our attention now to the softest form of precipitation, drizzle, those tiny droplets that seem to hang in the air rather than fall. Drizzle is defined as water droplets smaller than half a millimeter in diameter, about the size of a pinhead or smaller. These droplets are so small, so light, that they fall almost imperceptibly slowly, at less than 10 feet per second. On a drizzly day, you might not even notice you're getting wet at first. The moisture accumulates gradually, gently, like the slowest of paintbrushes adding layer upon translucent layer. There's no violence to drizzle, no urgency. It simply persists, patient and soft, sometimes for hours at a time. Drizzle forms in low-lying stratus clouds, those flat, gray blankets that settle over the landscape like a ceiling. These clouds don't have the strong updrafts that create larger raindrops. Instead, tiny droplets condense and merge together slowly, growing just large enough to overcome the faint updrafts holding them aloft. When they finally begin to fall, they descend through air that's already nearly saturated with moisture, so they don't evaporate on the way down. They simply drift, unhurried, completing their gentle journey from cloud to earth. Here's something remarkable about these tiny droplets. Because they're so small and fall so slowly, they're incredibly responsive to even the slightest movements of air. A drizzle droplet can be redirected by the tiniest breeze, can hover almost motionless in a slight updraft, can drift sideways as easily as downward. On a drizzly day, the rain doesn't really fall in straight lines, it wanders, meanders, floats on invisible currents. The boundary between cloud and air becomes blurred. You're not just under the cloud, you're inside it, surrounded by moisture that can't quite decide whether it's falling or floating. In some coastal regions, there's a phenomenon locals call Scotch mist, a drizzle so fine it's almost more like walking through a cloud than through rain. The droplets are microscopic, creating a silvery haze in the air. Your face becomes damp, your clothes gradually absorb moisture, but you never feel individual drops landing. It's the atmosphere itself becoming slightly liquid, a threshold state between air and water. Everything becomes softer in this mist, edges blur, sounds muffle, distances become uncertain. The world shrinks to just what's immediately around you. Drizzle has its own particular smell, different from heavier rain. Because the droplets are so small and fall so slowly, they have more time to interact with the air they're passing through. They collect particles of dust and pollen, molecules of various gases, carrying them down to earth. This creates a gentle, clean scent, not as dramatic as the petrichor of a thunderstorm, but subtler, fresher, like the smell of laundered linen or morning air. There's also something called verga, precipitation that falls from a cloud but evaporates before reaching the ground. You can see it sometimes as faint, hazy streaks beneath a cloud, like curtains of gray hanging in the sky. The rain begins its descent, the droplets fall through drier air below the cloud, and slowly, gradually, they diminish, growing smaller, lighter, until finally they disappear entirely, surrendering their moisture back to the atmosphere. It's rain that never completes its journey, that changes its mind midway and returns to vapor. There's something poignant and peaceful about this, precipitation that asks nothing of the earth, that simply cycles through its transformations and returns to where it began. Picture yourself now as one of these tiny drizzle droplets, barely falling, almost floating, taking long minutes to travel just a short distance, so small that the gentlest air current can hold you suspended, drifting through moist, gray stillness, no rush, no destination that can't wait, just this soft, slow descent, lighter than a whisper, quieter than thought, dissolving gradually into the stillness, letting go, letting go. Now let us drift into the realm of air pressure, that invisible force pressing gently against every inch of your body right now. The atmosphere above you weighs something, though you never feel its weight. At sea level, the column of air stretching from where you rest all the way up to the edge of space, about 60 miles high, presses down with a force of about 14.7 pounds on every square inch of your body. That means the air pressing on the palm of your hand weighs roughly as much as a bowling ball. Yet you feel nothing, because the air inside your body pushes outward with exactly the same force, creating perfect balance. You are held in equilibrium, supported equally from all directions, cradled by pressure you cannot sense. This pressure changes constantly, rising and falling in slow, gentle waves. High-pressure systems bring calm, clear weather. In these systems, air is slowly sinking from higher altitudes, spreading outward as it descends, creating vast domes of stable atmosphere hundreds of miles across. The descent is so gradual, perhaps just a few centimeters per second, that you'd never perceive it, yet this gentle downward motion suppresses cloud formation and brings those crystalline blue skies that seem to stretch forever. High pressure means stillness, clarity, peace. Low pressure systems are where air slowly rises, spiraling upward in broad, lazy circles. As the air rises and expands, it cools, and moisture condenses into clouds. But even in a low-pressure system, the upward movement is remarkably gentle, often no faster than a leisurely walking pace. These systems bring clouds and precipitation, but they do so gradually, patiently. Weather doesn't rush. Even storms take hours to organize themselves, to gather their strength. The atmosphere works on its own timescale, unhurried and deliberate. The difference between high and low pressure, the gradient that drives all weather, is often remarkably small. A pressure difference of just 1% between two locations can create a steady wind. The Earth's atmosphere is so sensitive to these tiny imbalances that even the smallest difference sets air in motion, always seeking to equalize, to smooth itself out. It's constantly rebalancing, adjusting, like a vast sheet of water finding its level across the entire planet. Here's something wonderfully subtle: your ears can detect pressure changes. When you drive up a mountain or take off in an airplane, you feel your ears pop as they adjust to the changing pressure. But your body is also sensing pressure changes too small to make your ears pop, the slow rise and fall of atmospheric pressure as weather systems pass overhead. Some people can feel these changes more acutely, sensing an approaching storm as a subtle shift in the air around them. Your body is in constant, unconscious conversation with the atmosphere, responding to pressures and changes you're not even aware of. Barometric pressure changes throughout the day in a predictable rhythm, even without weather systems moving through. It rises slightly in the late morning and late evening, and falls slightly in the early afternoon and before dawn. These changes are small, often less than 0.1%, but they happen every day, a gentle pulse synchronized with the heating and cooling of the atmosphere by the sun. The air breathes in and out, expands and contracts, in a daily rhythm as regular as your own heartbeat. In some parts of the world, the barometric pressure remains remarkably stable for days or even weeks at a time. The tropics, for instance, experience very little pressure variation. The trade winds blow steadily, the pressure stays nearly constant, and each day feels remarkably like the last. There's a particular tranquility in this constancy, weather that doesn't shift and change dramatically, but simply continues, reliable and predictable, day flowing into night flowing into day again. So rest now in this knowledge: you are held by invisible pressure, balanced perfectly inside and out, the atmosphere pressing against you with the weight of miles of air, yet you feel only comfort, only support, pressure rising and falling around you in slow waves, tides of air flowing across continents, and you, resting peacefully at the bottom of this ocean of atmosphere, held, supported, perfectly balanced, perfectly still. Let's drift now into the world of temperature, that invisible quality of air that your skin perceives moment by moment without effort. Temperature is simply the measure of how fast molecules are moving. In warm air, molecules vibrate and bounce more rapidly. In cool air, they slow down. But even in the coldest air you might experience, molecules are still moving at hundreds of miles per hour, they never truly stop. What you perceive as warmth or coolness is just your skin detecting this molecular motion, sensing whether the air around you is transferring energy to you or drawing it away. It's one of the most intimate forms of contact with the atmosphere, this constant exchange of heat, this molecular conversation happening across every inch of your skin. The Earth's temperature has its own gentle rhythm. Each day, the coolest moment typically comes just before dawn, when the Earth has been radiating heat into space all night long and the sun hasn't yet begun to warm it again. This is when dew forms most heavily, when the air is most still, when the world seems to hold its breath before the new day begins. Then, gradually, the sun rises, and temperatures climb slowly, steadily, reaching their peak not at noon when the sun is highest, but usually around 2 or 3 in the afternoon. This delay happens because the Earth takes time to absorb the sun's energy and re-radiate it as heat. Everything moves slowly, nothing rushes. Here's a peaceful thought: the sun warming your skin right now began its journey 93 million miles away, traveling for 8 minutes and 20 seconds through the vacuum of space before reaching you. The light touching you now left the sun while you were doing something else entirely, perhaps sleeping, perhaps reading, perhaps lost in thought. And it traveled all that distance, unchanging and patient, just to warm you in this moment. Every ray of sunlight is a time traveler, bringing you warmth from the past. Temperature also changes as you move upward through the atmosphere, but not always in the way you might expect. In the troposphere, where we live, temperature drops about 3.5 degrees Fahrenheit for every 1,000 feet you climb. This is why mountain peaks are snow-covered even in summer, why the air grows cooler as you hike upward. But then, something curious happens. In the stratosphere above, temperature begins to rise again with altitude. In the mesosphere beyond that, it falls. In the thermosphere higher still, it rises dramatically. The atmosphere is layered like a cake, each layer with its own temperature profile, creating a complex vertical structure that extends from your feet to the edge of space. On a perfectly clear night, the ground can become colder than the air just above it. Heat radiates away into space from the Earth's surface, and a thin layer of very cold air forms right at ground level. This is called a temperature inversion, and it creates those magical mornings when frost covers the ground but the air at head height is still above freezing. The coldest air settles like an invisible pool, and everything it touches, grass, car roofs, spider webs, becomes coated with delicate ice crystals while the air above remains clear and relatively warm. Water has a remarkable ability to moderate temperature. Oceans, lakes, and even moist soil warm up more slowly during the day and cool down more slowly at night than dry land. This is because water has a high heat capacity. It takes a lot of energy to change its temperature. Coastal areas experience this as milder, more stable temperatures. The ocean acts like a vast thermal battery, storing heat during summer and releasing it during winter, smoothing out the extremes. Places near large bodies of water rarely get as hot or as cold as inland locations at the same latitude. They exist in a gentler climate, moderated by water's patient retention of heat. Even your own body maintains a constant temperature of about 98.6 degrees Fahrenheit, regardless of whether the air around you is freezing or sweltering. Your metabolism generates heat continuously, and your body adjusts, sweating when you're too warm, shivering when you're too cool, all automatically, all without conscious thought. Right now, as you rest, your body is performing countless tiny calibrations, maintaining perfect thermal balance, keeping you comfortable without any effort from you. Let yourself settle into this. You are surrounded by air of a particular temperature, molecules moving at a particular speed, transferring warmth in a gentle equilibrium, your body adjusting effortlessly to the conditions around you, temperature rising and falling in slow daily rhythms, heat flowing invisibly from warm to cool, always seeking balance, and you, resting at the center of it all, perfectly regulated, perfectly maintained, warm enough, cool enough, just right. Just as you are. Now let us turn to moonlight and its subtle influence on the weather around us. The moon pulls at the earth with its gravity, creating tides in the oceans, but it also creates tides in the atmosphere itself. These atmospheric tides are invisible, imperceptible to us, but they're real. The air rises and falls by just a few centimeters as the moon passes overhead, creating the tiniest of pressure changes. It's the atmosphere breathing in rhythm with the moon's orbit, a connection between Earth and sky and distant satellite, all moving together in gravitational harmony. You are part of this cosmic dance, standing on a planet whose very air responds to the pull of the moon. Moonlight itself is just reflected sunlight, photons that traveled from the sun to the moon and then bounced back to Earth. These photons have taken a longer journey than direct sunlight, about 2.5 seconds longer, because they had to travel the extra distance to the moon and back. When you see moonlight, you're seeing sunshine that took a detour, light that visited another world before arriving at your eyes. And moonlight is surprisingly dim, about 400,000 times fainter than direct sunlight, yet still bright enough to cast shadows, to illuminate clouds, to turn the landscape into shades of silver and gray. On clear, calm nights when the moon is full, temperatures tend to drop more slowly than on moonless nights. The moon's light, faint as it is, carries just enough energy to slightly slow the cooling of the Earth's surface. It's a tiny effect, perhaps only a degree or two, but it's measurable. Even that pale, reflected light has warmth in it, has energy, has the ability to touch the Earth and change it in small ways. The phases of the moon create their own rhythm in the night sky: new moon, crescent, half, gibbous, full, and back again in a cycle that takes 29.5 days. This lunar month is slightly different from our calendar months, creating a slow drift where full moons occur at different times each month. But the cycle itself is ancient, unchanging, one of the most reliable rhythms in nature. Humans have watched this cycle for thousands of generations, farmers have planted by it, sailors have navigated by it, poets have written by its light. The moon's phases are a clock in the sky, marking time in gentle increments. Here's something almost magical: on very rare occasions, when the air is exceptionally clear and stable, you can see what's called a moon pillar, a vertical shaft of light extending above or below the moon. This happens when moonlight reflects off tiny ice crystals floating horizontally in the air, all aligned like millions of tiny mirrors. The light bounces off these crystals and reaches your eyes, creating the illusion of a column of luminescence hanging in the sky. It's moonlight made visible in its path through the atmosphere, rendered tangible by ice. The moon also influences dew formation in subtle ways. On clear nights with a full moon, the slight additional warmth from moonlight can mean the difference between dew forming or not forming at a particular location. The boundary between temperatures that allow condensation and temperatures that don't is often razor thin, just a fraction of a degree. The moon's gentle light can tip that balance, affecting which surfaces collect moisture and which remain dry. In polar regions during summer, when the sun never sets, the moon still rises and sets, passing through the perpetual daylight. You can sometimes see it as a pale disk in the bright sky, a ghost of itself, present but barely visible. It's a reminder that the moon is always there, always orbiting, always pulling at the Earth with its gravity, whether we can see it or not. Day or night, cloudy or clear, the moon continues its ancient circuit, patient and eternal. So let the image of moonlight settle over you now, pale photons that traveled from sun to moon to earth, carrying their faint warmth, the moon pulling gently at the atmosphere above you, creating invisible tides in the air, ice crystals aligning themselves to reflect that distant light, everything moving in slow celestial rhythms, the moon waxing and waning in its endless cycle, and you, resting beneath it all, bathed in reflected light, held by gravity, part of these ancient patterns, safe, still, drifting like the moon across the sky. Let us drift now into the quietest hours, into the deep stillness that settles over the world in the middle of the night. There is a particular quality to the air between midnight and dawn. The earth has been cooling for hours, radiating its daytime warmth into the vastness of space. The atmosphere settles, layering itself by temperature and density like oil and water finding their natural separation. The air becomes stratified, stable, resistant to mixing. Winds die down to almost nothing. This is when the atmosphere is at its most peaceful, its most still. Meteorologists call this period the nocturnal boundary layer, a thin shell of calm air that wraps around the sleeping earth. During these hours, sounds travel differently. Without the turbulence created by the sun heating the ground, sound waves can travel farther, bending and reflecting in unusual ways. You might hear distant trains more clearly at 3 in the morning than at 3 in the afternoon. A dog barking half a mile away sounds closer. The atmosphere becomes a better conductor of sound when it's stratified and still, creating acoustic conditions that exist only in the deepest part of night. The world is quiet, but also more resonant, more alive to the sounds that do occur. This is also when many clouds dissipate. Without the sun's energy to drive convection and create updrafts, clouds that formed during the day slowly evaporate. The water droplets return to invisible vapor, molecule by molecule, and the sky clears. By dawn, skies that were partly cloudy at sunset are often completely clear, revealing stars that were hidden hours before. The clouds dissolve back into the air they came from, completing their brief existence, leaving no trace except the moisture they've returned to the atmosphere. In valleys and low-lying areas, cold air pools and deepens through the night. This is the time when frost is most likely to form, when mist thickens into fog, when the coldest temperatures of the entire 24-hour cycle occur. The earth has given away all the heat it's going to give. It waits now, in patient coldness, for the sun to return and begin the warming cycle again. There's something profound in this waiting, the earth in its coldest, stillest state, poised in the moment just before renewal. Here's a thought to carry you deeper into rest. While you sleep, the atmosphere continues its work. Water evaporates from oceans and lakes. Molecules drift upward on faint currents. Dew condenses on a billion blades of grass. Temperatures equalize across vast distances. Pressure systems shift and adjust. The atmosphere never sleeps, never stops its endless circulation, its patient redistribution of heat and moisture around the planet. While you rest, the weather continues, faithful and constant, asking nothing of you. There's a meteorological phenomenon called radiational cooling that happens on clear, calm nights. The Earth's surface radiates infrared energy, heat, directly into space without anything to trap it. On cloudy nights, clouds act like a blanket, reflecting this heat back down. But on clear nights, the heat escapes freely, and temperatures can drop dramatically. The clearest, calmest nights are often the coldest, not because cold air has moved in, but simply because warmth has moved out, radiated away into the infinite darkness above. The earth gives its heat to the universe, a gift that travels outward forever at the speed of light. And as dawn approaches, still an hour or more away, the atmosphere begins to anticipate the sun. The very highest clouds, if any remain, catch the first light while the ground is still in darkness. The temperature stops falling and steadies. Birds begin to stir. The nocturnal boundary layer starts to break down, preparing for the mixing and turbulence that daylight will bring. But this happens so gradually, so gently, that the transition is barely perceptible. Night doesn't end abruptly, it fades, softens, dissolves into gray, then blue, then gold. Let yourself sink now into this deepest part of night, the earth at its coolest, the air at its most still, sounds traveling clearly through the stratified quiet, clouds dissolving back into invisible vapor, the atmosphere working patiently through its cycles while you rest, asking nothing, needing nothing from you, just continuing its ancient patterns, breath after breath of the sleeping earth, cooling, settling, waiting in perfect darkness, perfect peace, for the light that will surely come, but not yet, for now, only this deep, quiet, rest. Let us turn now to the gentle world of evaporation, that invisible transformation happening all around you, always. Every body of water on Earth is slowly, constantly releasing molecules into the air. A lake, a puddle, even a glass of water sitting on a table, each one is surrendering water molecules to the atmosphere, one by one, in an endless quiet procession. At the surface of the water, some molecules have enough energy to break free from their liquid bonds and drift upward as vapor. This happens without sound, without visible change, at every moment of every day. The world is full of this patient transformation, this gentle crossing from liquid to gas. The rate of evaporation depends on several peaceful factors. Warmer water releases molecules more readily, heat gives them the energy to escape. Drier air accepts more molecules, there's more room for them in unsaturated air. A light breeze helps by carrying away the water vapor that accumulates just above the surface, making space for more molecules to join the air. But even without these ideal conditions, evaporation continues. Even in cool, humid, still air, some water molecules always manage to break free. The process is inevitable, unstoppable, as natural as time itself. Here's something remarkable: when a water molecule evaporates, it takes heat energy with it. This is why sweating cools you down, why a wet cloth feels cool against your skin. Each departing molecule carries away a tiny amount of thermal energy, leaving the remaining water slightly cooler. This is evaporative cooling, and it's happening constantly wherever water meets air. A lake evaporating on a summer day is cooling itself molecule by molecule. The Earth uses this process to regulate its temperature, transforming liquid water into vapor and, in doing so, moving heat from the surface into the atmosphere. Oceans evaporate about 320,000 cubic miles of water every year. That's an almost incomprehensible amount, enough to cover the entire United States in a layer of water 4 feet deep. Yet this happens so gradually, so evenly distributed across the vast ocean surfaces, that you'd never notice it looking at any particular spot. The ocean level doesn't drop because rivers and rainfall return the water continuously. It's a perfect balance, water cycling endlessly between ocean and sky and earth, with evaporation as the quiet engine driving the whole system. Even ice evaporates, though we call it sublimation when a solid transforms directly into gas without becoming liquid first. In dry, cold conditions, like on a winter day with bright sun and low humidity, snow can disappear without ever melting. The ice molecules absorb enough energy from the sunlight to break free and drift away as vapor. The snow doesn't leave puddles, it simply vanishes into the air. This is how snow disappears from roads and sidewalks on cold, sunny days even when temperatures stay below freezing. The snow returns to the atmosphere, patient and unhurried, completing its transformation. Plants participate in this cycle too, through a process called transpiration. Water absorbed by roots travels up through stems and trunks to leaves, where it evaporates through tiny pores called stomata. A large tree can transpire hundreds of gallons of water on a summer day, releasing it as vapor into the air above the forest. Trees are living fountains, pulling water from the soil and gifting it to the sky. When you walk through a forest on a humid day, much of that moisture in the air came from the trees themselves, breathed out through countless leaves. The atmosphere holds about 3,100 cubic miles of water vapor at any given moment, enough to cover the entire Earth in 1 inch of rain if it all fell at once. But it doesn't all fall at once. Instead, it moves through the cycle at its own pace, evaporating, rising, condensing, falling, collecting, and evaporating again. Each molecule takes about 9 days, on average, to complete the journey from ocean to sky to land and back to ocean again. 9 days of transformation, travel, and return. Let this image settle over you now. Water molecules rising from lakes and oceans, one by one, each one carrying a tiny amount of heat, drifting upward into the cooler air above, invisible, silent, patient, trees breathing moisture into the forest air, puddles slowly shrinking in the sun, everything evaporating at its own gentle pace, and you, resting quietly, breathing this moisture-filled air, molecules that were once part of oceans, lakes, rivers, rain, now part of the air around you, soon to transform again, always moving, always cycling, never rushing, never still. Now let us drift into the soft world of morning mist, that ethereal presence that transforms landscapes into dreams. Mist is simply fog that is less dense, where visibility is greater than half a mile but the air still holds suspended water droplets. It creates that softened world where objects fade gradually into whiteness, where distances become uncertain, where everything takes on a muted, gentle quality. Mist often forms in the early morning hours over bodies of water or in low-lying areas where cool, moist air settles. It's the atmosphere hovering at the exact threshold between air and cloud, neither fully one nor the other. Steam fog, also called sea smoke, forms when cold air moves over warmer water. The water evaporates into the cold air above it, immediately condensing into fog that rises in wisps and tendrils like smoke from a fire. You see this often on autumn mornings over lakes and rivers, delicate columns of mist rising vertically, curling and twisting as they ascend, then dissipating as they reach warmer air above. It looks like the water is breathing, exhaling visible breath into the cool morning. Each wisp is a small convection current, warm moist air rising through cooler air, creating those ghostly shapes that dance across the water's surface. There's a particular peacefulness to the way mist dampens sound. Just like fog, mist absorbs sound waves, creating that hushed quality where even your own footsteps seem quieter. birds sound more distant. Water lapping at a shore becomes muffled. The world contracts to what's immediately around you, and everything beyond fades into soft obscurity. In mist, you exist in a small pocket of clarity surrounded by mystery, and there's something deeply calming about this, being held in a space where the distant world doesn't demand your attention. Mist droplets are larger than the droplets in clouds but smaller than drizzle, typically between 10 and 50 micrometers across. They're large enough to settle very slowly through the air, yet small enough to remain suspended for hours. A mist droplet might take 30 minutes to fall just 20 feet, drifting down so slowly that any faint updraft can hold it aloft indefinitely. When you walk through mist, you're moving through millions of these tiny droplets, each one hanging in the air, each one catching and scattering light. Mountain mist has its own character. As moist air flows up mountain slopes, it cools and forms mist that clings to the mountainside, flowing around rocks and trees like a slow river. This orographic mist can persist for days in the right conditions, keeping mountain forests perpetually damp, creating ecosystems that depend on this constant moisture. There are cloud forests in tropical mountains where mist is present more days than not, where trees are draped with moss and ferns that drink directly from the air, where water drips constantly even when it's not raining. The mist is their life source, more reliable than rain. Here's something beautiful to contemplate: mist creates halos around lights. Street lights, headlights, even the moon, all develop soft glowing circles when viewed through mist. This happens because the water droplets scatter light, bending it around themselves and creating these luminous rings. The size of the halo depends on the size of the droplets. Smaller droplets create larger halos. On a misty night, every light source becomes softened, diffused, transformed into something gentler than itself. The world becomes a place of glowing orbs floating in whiteness. As morning progresses and the sun rises higher, mist usually burns off gradually. The sun's warmth increases the air's capacity to hold water vapor, and the tiny droplets evaporate, returning to invisible vapor. The mist doesn't blow away, it simply disappears, thinning from the top down as the upper layers warm first. You can watch this happen, the mist becoming less dense minute by minute, visibility gradually increasing, the world slowly revealing itself as if emerging from behind a veil. And then, often quite suddenly, the last wisps dissolve and the air is clear again, as if the mist had never been there at all. Rest now in this image. You are surrounded by soft mist, suspended droplets hanging motionless in the air around you, light diffused into gentle glows, sounds muffled and distant, the world reduced to what's immediately present, everything beyond fading into peaceful obscurity, droplets so small they barely fall, drifting in the still air, the boundary between earth and sky dissolved into whiteness, and you, held in this soft space, where nothing is urgent, nothing is clear, everything is gentle, soft, fading, fading. Let us float now into the world of rainbows, those gentle arcs of color that appear when light and water meet. A rainbow is sunlight that has passed through millions of raindrops, each drop acting as a tiny prism. The light enters the drop, bends, reflects off the back surface, and bends again as it exits. Different wavelengths of light bend by slightly different amounts, separating into the spectrum of colors we see: red, orange, yellow, green, blue, indigo, violet. Each raindrop produces the full spectrum, but from where you stand, you see only one color from each drop. The red you see comes from drops at a slightly different position than the drops producing the violet. Millions of raindrops, each contributing one color, create the arc you perceive. Here's something peaceful to know: you can never reach the end of a rainbow. As you move, the rainbow moves with you, always maintaining the same angle between the sun, the raindrops, and your eyes. The rainbow isn't really at any particular location, it's an optical effect that exists only in the relationship between light source, water, and observer. Two people standing in different places see slightly different rainbows, created by different sets of raindrops. Your rainbow is yours alone, visible only from where you stand, existing only for as long as you're there to see it. Rainbows always appear in the part of the sky opposite the sun. If the sun is behind you and to your left, the rainbow will be in front of you and to your right. The sun must be less than 42 degrees above the horizon for you to see a rainbow. If it's higher, the rainbow arc would be below the horizon, invisible. This is why rainbows are most common in the late afternoon or early morning, when the sun is lower in the sky. They're phenomena of transitional times, appearing in those gentle hours when day is beginning or ending. Sometimes, if conditions are perfect, you can see a double rainbow. The second, fainter rainbow appears above the primary one, with its colors reversed, violet on the outside, red on the inside. This happens when light reflects twice inside the raindrops instead of once. The second reflection reverses the order of colors and spreads them over a wider arc, making the secondary rainbow dimmer and larger. Between the two rainbows is a darker band of sky called Alexander's band, where raindrops aren't sending light to your eyes. It's a stripe of shadow amidst the color. Rainbows can also appear in mist, spray, or fog, anywhere there are water droplets suspended in air and sunlight coming from behind you. Waterfalls often create rainbows in their mist. Garden sprinklers on sunny days produce small rainbows that move as you move. Even dewdrops on grass can create tiny rainbows if the angle is just right. The phenomenon is always the same: light, water, geometry. Simple elements combining to create something that feels like magic. At night, when the moon is bright and full, you can sometimes see a lunar rainbow, a moonbow. These are much fainter than solar rainbows because moonlight is so much dimmer than sunlight, often appearing almost white to our eyes, which don't perceive color well in low light. But cameras with long exposures can capture their colors. Moonbows require the same conditions as daytime rainbows. The moon must be less than 42 degrees above the horizon, and there must be rain or mist in the opposite part of the sky. They're rare and ethereal, ghosts of their daytime counterparts. There's also something called a circumzenithal arc, sometimes called an upside-down rainbow. This appears as a colorful arc high in the sky, curving upward rather than downward, created by sunlight refracting through ice crystals and high cirrus clouds rather than through raindrops. It's often more intensely colored than a regular rainbow, with vivid, saturated hues. These arcs are brief and uncommon, requiring very specific angles between sun, ice crystals, and observer. When you see one, you're witnessing light performing a different dance, taking a different path through a different medium, but still separating into that same eternal spectrum. Let yourself rest now with this thought: light traveling from the sun, passing through water, bending and separating into colors, millions of drops working together to paint an arc across the sky, a rainbow that exists only for you, from your exact position, in this exact moment. Colors that appear and disappear as drops fall and are replaced by other drops, Nothing permanent, nothing solid, just light and water and geometry, creating beauty that lasts only minutes, then fades, dissolves, returns to colorless light and transparent water, leaving only the memory, soft, fading, gone. Let us drift now into the quietest of all weather, the calm. Perfect calm is rare. It's defined meteorologically as wind speeds of less than 1 mile per hour, air so still that smoke rises vertically without the slightest deflection, that leaves hang motionless on trees, that the surface of a pond becomes a flawless mirror. In these moments, the atmosphere has achieved a temporary equilibrium. Pressure differences have smoothed out. Temperature gradients have equalized. The air simply rests, suspending its endless circulation for a brief, precious interval. These moments of calm often occur during what's called a call, a neutral zone between weather systems where neither high nor low pressure dominates. It's the atmospheric equivalent of the still point at the center of a seesaw, perfectly balanced. Or calm can settle during the night, when the Earth's surface cooling creates stable conditions that suppress air movement. The atmosphere settles into layers, each at its own temperature, with no energy to mix them. Everything becomes stratified, ordered, still. In perfect calm, sounds carry with unusual clarity. Without wind to scatter and distort sound waves, you can hear things from surprising distances, a dog barking miles away, a door closing across a valley, voices from much farther than usual. But at the same time, there's an absence of the background noise that wind creates. No rustling leaves, no whistle around buildings, no white noise of moving air. The silence becomes profound, almost tangible. You become aware of sounds you normally never notice, your own heartbeat, your breath, the small sounds of your own movement. Water surfaces in perfect calm become extraordinary mirrors. Lakes reflect the sky and surrounding landscapes so perfectly that it becomes difficult to tell where water ends and air begins. The reflection is not distorted by ripples or waves. Every detail, clouds, trees, mountains, appears twice, once above and once below, creating symmetrical worlds. Photographers wait for these moments, when the boundary between reality and reflection dissolves, when the world doubles itself in perfect stillness. Here's a thought to carry you deeper. In calm air, scents travel differently. Without wind to disperse them quickly, fragrances linger and settle, creating layers of smell at different heights. The scent of flowers might hang at head level while the smell of earth stays closer to the ground. You can walk through invisible pockets of fragrance that remain stationary in the still air. The world becomes not just visually peaceful but olfactorily stratified, each scent finding its own level and staying there. Even your own breathing creates movement in perfectly calm air. The warmth and moisture of your exhaled breath rises gently, creating a tiny personal current, a minute disruption in the stillness. In cold weather, you can see this as your breath condenses into visible vapor, rising straight up in a delicate column. You become aware of yourself as a source of heat, of moisture, of gentle disturbance in the otherwise motionless atmosphere. Your very presence creates weather on the smallest scale. Calm conditions are often temporary, transitional states. They appear between weather systems, in the eye of storms, during shifts between day and night patterns. There are pauses in the atmosphere's constant activity, moments when the machinery of weather briefly idles. But even in these moments, change is brewing. Pressure differences are developing elsewhere. Temperature gradients are forming. The calm is gathering energy, preparing for movement. The atmosphere never truly rests for long, it only appears to, holding itself in check before resuming its eternal circulation. There's a particular quality of light during calm conditions, especially near dawn or dusk. Without wind to stir up dust or disturb the atmosphere, visibility can become exceptionally clear. Colors appear more saturated. Distant objects seem closer than they are. The air itself seems to vanish, becoming perfectly transparent. You can see for miles with unusual clarity, every detail sharp, as if the atmosphere has temporarily ceased to exist between you and the horizon. Everything is visible. Everything is clear. Everything is still. Let yourself settle into this stillness now, air so calm it barely exists, no movement, no breeze, no rustle or whisper, just perfect, profound quiet, your breath rising in a gentle column above you, sounds carrying clearly through the motionless air, the world reflected perfectly in still water, scents hanging suspended at their own levels, everything clear, everything visible, everything at rest, and you, at the center of this calm, breathing slowly, being still, becoming stillness itself, peaceful, quiet, perfectly still. Now let us turn to the gentle phenomenon of condensation, water finding its way back to visibility. Condensation is the atmosphere exhaling. All that invisible water vapor suspended in the air, carrying its moisture patiently, waiting, finds a cool surface and transforms back into liquid. A cold glass of water on a warm day becomes beaded with droplets. A bathroom mirror after a shower clouds with moisture. Grass at dawn collects dew. These are all the same process, water vapor touching something cooler than itself and letting go of its gaseous form, returning to liquid, molecule by molecule, in perfect silence. Each droplet of condensation begins with a single molecule of water vapor finding a tiny imperfection, a microscopic scratch on glass, a speck of dust, a slight indentation. This first molecule clings to the surface, and others join it, one after another, building the droplet larger and larger. Eventually, the droplet becomes heavy enough to slide down the surface, gathering other droplets as it goes, merging and growing until it drips away. This happens on windows, on car windshields, on the outside of pipes, on leaves. Everywhere that cool surfaces meet moisture-laden air, this quiet accumulation takes place. Here's something soothing: condensation releases heat. When water vapor condenses into liquid, it gives up the energy it used to become vapor in the first place. This is called latent heat, and it's the same energy that was absorbed when the water evaporated. When clouds form through condensation, they actually warm the air around them slightly. When dew forms on grass, tiny amounts of heat are released into the cool night air. The process of water changing state is always accompanied by this gentle exchange of energy, cooling when it evaporates, warming when it condenses, helping to regulate temperatures, smoothing out extremes. Condensation is what creates clouds, of course. Water vapor rising in the atmosphere encounters cooler temperatures at higher altitudes. Eventually, the air cools enough that it can no longer hold all its moisture as vapor, and condensation begins around tiny particles of dust, salt, or pollen. Billions upon billions of droplets form, suspended in the air, and we see this as a cloud. The cloud is condensation made visible, water that was invisible becoming something we can see, something that casts shadows and reflects light and drifts across the sky. Inside your home right now, condensation is happening in hidden places. In the small gap between a window and its frame. On the cold metal of pipes. On the backs of mirrors. In corners where air circulation is poor and surfaces are cool. Your house breathes moisture, and that moisture finds every cool surface to condense upon. In winter, ice sometimes forms on the inside of windows in old houses, condensation that froze because the window was so cold. These are tiny weather systems existing in the spaces where you live, microscopic climates governed by the same principles that create weather outside. Condensation trails, contrails, form behind high-flying aircraft when hot, moist exhaust meets the extremely cold air of the upper atmosphere. The water vapor in the exhaust immediately condenses and often freezes into ice crystals, creating those white lines across the sky. These artificial clouds can persist for hours if the air is humid enough, sometimes spreading and merging with other contrails to form thin sheets of cloud. They're human-made weather, our machines creating condensation at altitudes where natural clouds are rare. Each line is a record of a journey, written temporarily across the sky. Even your breath creates condensation. On a cold day, the warm, moist air from your lungs meets the cold air outside, and the moisture instantly condenses into tiny droplets, your breath made visible. Every exhalation becomes a small cloud, a personal fog that forms and disperses in seconds. Children delight in this, breathing dragons of vapor into winter air. But it's happening even when you can't see it. Every breath releases moisture into the air around you, moisture that eventually finds a cool surface somewhere and condenses, becoming part of the world's water cycle once again. Rest now with this image, water vapor all around you, invisible and patient, finding cool surfaces, condensing molecule by molecule, droplets forming in silence, growing, merging, releasing their gentle warmth as they transform, your own breath adding moisture to the air accepting it, carrying it, until it finds its place to rest, to become visible again, to complete its transformation, slow, quiet, inevitable, like sleep itself, condensing, settling, finding peace. Let us drift now into the world of gentle precipitation, the softest ways that water returns to earth. There exists a form of precipitation so light it has its own name, virga. We touched on this earlier, but let us settle into it more deeply now. Virga is rain that never reaches the ground. You can see it as gray streaks beneath a cloud, like curtains hanging in the sky, precipitation falling but evaporating as it descends through drier air below. The drops grow smaller and smaller as they fall, surrendering their moisture back to the atmosphere, until finally they disappear completely. It's rain that changes its mind, that begins the journey but doesn't complete it. There's something gentle and forgiving about this, precipitation that asks nothing of the earth, that simply practices falling, then returns to where it began. Light rain, officially defined as less than 0.10 inches per hour, is one of the most peaceful forms of weather. Individual drops are small and widely spaced. They patter softly on leaves and rooftops. You can often walk in light rain without becoming very wet, the drops so sparse and small that they barely penetrate clothing. There's no urgency to light rain, no violence. It's the atmosphere releasing moisture in the gentlest possible way, one small drop at a time, distributed evenly, unhurried. Rain has a rhythm that's been measured scientifically but felt intuitively by everyone. The sound of rain on a roof follows patterns, starts, stops, intensifications, easings, that create a kind of natural music. Studies have shown that the sound of rain can slow heart rates and brain waves, inducing relaxation and sometimes sleep. The white noise of raindrops, the gentle percussion, the unpredictability within a consistent pattern, all of these elements combine to create something deeply soothing to the human nervous system. We evolved hearing rain. It's programmed into us as a sound of safety, of shelter, of being protected while nature washes the world. Each raindrop that falls has been cycling through the water cycle for billions of years. The drop hitting your window right now might have fallen as rain over ancient forests, been absorbed by dinosaurs, evaporated from prehistoric seas, frozen in ice age glaciers, traveled through countless clouds, and fallen as rain millions upon millions of times before this moment. Water is never created or destroyed, it only transforms and moves. The same water, endlessly cycling, endlessly patient, fulfilling its role in the planet's system without complaint, without exhaustion. There's a particular quality of air during light rain, fresh, clean, slightly cool. The rain washes particles from the air as it falls, collecting dust and pollen and carrying them to the ground. Each drop is a tiny scrubber, cleansing the atmosphere molecule by molecule. After rain, the air is measurably cleaner, clearer. Visibility improves. Breathing feels easier. The rain has done its work of purification, leaving the atmosphere renewed. Some cultures have dozens of words for different types of rain. The Scots have smurf for light, misty rain. Norwegians have your for fine, drizzly rain. The Japanese distinguish between sudden rain showers and gentle continuous rain with different words. These distinctions recognize what we all sense, that not all rain is the same, that each type has its own character, its own feeling, its own particular way of touching the earth. Light rain is contemplative. Drizzle is persistent. Showers are brief and changeable. Each teaches us something different about patience, about acceptance, about the many moods of water falling from sky. Here's a final peaceful thought about rain. It's one of the only weather phenomena that makes a sound you can hear from inside. Wind, you feel. Clouds, you see. But rain, you hear, even through walls, even through windows, even when you're wrapped warmly inside. Rain announces itself through sound, creating an acoustic shelter around you. You're inside, dry and protected, and the rain reminds you of this comfort with every patter, every drop. It's the sound of being safe, of being home, of being held while the world outside receives its blessing of water. Let yourself rest now in the image of light rain, small drops falling slowly, widely spaced, pattering gently on leaves and earth, some drops evaporating before they land, others completing their journey, all of them part of water that has fallen countless times before, cleansing the air as they descend, creating soft rhythms, washing the world, while you rest inside, dry, warm, listening to the gentle sound, feeling your heartbeat slow, your breathing deepen. Your body relax, falling, gently falling, like rain, like sleep. Now let us turn our thoughts to the horizon, that distant line where earth meets sky. The horizon is always approximately 3 miles away if you're standing at sea level. This is due to the curvature of the earth. Your eyes can only see so far before the planet's curve blocks your view. Climb higher, and the horizon retreats. Stand on a mountain, and you can see for dozens of miles. But at ground level, that line where sky touches earth is always about 3 miles distant, a boundary that moves with you, forever maintaining the same distance no matter how far you walk toward it. The atmosphere does something beautiful at the horizon. Light from the sky has to travel through more air to reach your eyes when you look toward the horizon than when you look straight up. This extra distance through the atmosphere scatters more of the blue light, which is why the sky appears paler, almost white, near the horizon, and deeper blue overhead. At sunset, this effect becomes even more pronounced. Light travels through so much atmosphere that only the reds and oranges make it through, creating those spectacular colors we associate with evening. There's a phenomenon called the green flash that can occur just as the sun sets or rises. For a brief moment, sometimes only a second or two, the very last or first glimpse of the sun appears green rather than yellow or red. This happens because the atmosphere acts like a prism, bending different colors of light by different amounts. The green wavelength is bent just enough that it's the last color visible after the reds and yellows have dipped below the horizon. It's rare and requires exceptionally clear air, but those who've seen it describe it as a fleeting emerald jewel, a secret the atmosphere shares only occasionally. The horizon also marks a boundary in cloud formation. Clouds form and move in three-dimensional space, but from where you stand, distant clouds appear to touch the horizon, creating the illusion that sky and earth meet there. In reality, those clouds might be thousands of feet above the ground, but perspective compresses them, making them seem to rest on that distant line. The horizon is partly real, where your view is blocked by Earth's curve, and partly illusion, a trick of perspective and atmosphere. Mariners have used the horizon for navigation for thousands of years. The line where sea meets sky is perfectly level, unaffected by waves, providing a reference point for measuring the height of stars and sun. A sextant uses the horizon as its baseline. Even in a rocking ship on turbulent seas, the horizon remains geometrically true, a dependable line in a world of motion. There's something deeply reassuring about this. No matter how rough the sea, no matter how fierce the storm, the horizon persists, level and true. Haze and humidity affect how far you can see to the horizon. On a perfectly clear day with dry air, you might see the full 3 miles or more with exceptional clarity. On a humid day, water vapor in the air scatters light, reducing visibility. The horizon becomes indistinct, fuzzy, sometimes barely visible at all. Distance fades into whiteness. This is why desert horizons often appear sharp and clear. The dry air allows light to travel without much scattering, while coastal horizons are often softened by moisture, creating that hazy, dreamlike quality where sea and sky blend together. At night, the horizon disappears entirely unless there's moonlight or artificial light to define it. Sky and earth become one continuous darkness. Sailors call this no horizon, and it can be disorienting, removing that visual reference that helps us orient ourselves in space. But there's also something peaceful about it, the dissolution of boundaries, the merging of above and below into one seamless void. You're suspended in darkness, with stars above and darkness below, and no clear line dividing them. Let this image settle over you now, the horizon 3 miles distant, always the same distance no matter how you move, a line where Earth curves away from view, where light travels through extra atmosphere and changes color, where clouds appear to touch ground but float in space, a boundary both real and illusion, level and true even when the world moves, softened by moisture or sharpened by dryness, disappearing at night into seamless dark, and you, resting here, the horizon, encircling you in all directions, defining your visible world, containing you in a circle of perception, peaceful, bounded, held. Let us settle now into the gentlest thought of all, the predictability of weather patterns, the reliable rhythms that repeat day after day, season after season. Despite all its apparent randomness, weather follows patterns. The sun rises and sets at predictable times. Seasons progress in their ordained order. Trade winds blow consistently from the same directions. Ocean currents follow the same paths year after year. Beneath all the variation, all the daily changes, there are deep rhythms that never falter. The earth spins. The sun warms. Air moves from high pressure to low. Water evaporates and condenses and falls and evaporates again. These patterns have repeated for billions of years and will continue long after we're gone. The diurnal cycle, the daily pattern of temperature change, is one of the most dependable rhythms in nature. Coolest just before dawn. Warming through the morning. Warmest in mid-afternoon. Cooling through evening and night. This happens every single day, everywhere on Earth, varying only in magnitude. You can set your internal clock by it. Your body expects it. This rhythm is so fundamental that it's encoded in your cells. Your circadian rhythm matches the cycle of day and night, temperature and darkness, warmth and cool. Seasons, too, follow their ancient pattern. Spring brings warming and renewal. Summer brings heat and long days. Autumn brings cooling and harvest. Winter brings cold and dormancy. This four-part cycle has repeated as long as the Earth has tilted on its axis. Cultures have built their entire calendars around these seasons, planting and harvesting, celebrating and resting in accordance with this grand pattern. There is deep comfort in this repetition, knowing that winter always yields to spring, that summer will come again, that the wheel turns and returns. Even storms follow patterns. Hurricane season runs from June through November in the Atlantic. Monsoons arrive in India with remarkable regularity each summer. The rainy season in the tropics, the dry season in the Mediterranean, the tornado season in the American plains, all of these arrive on schedule, year after year. Meteorologists can predict not individual storms, but the patterns of when and where storms are likely to form. Nature is not random. It's complex, yes, but governed by laws that produce regularity within variation. Here's something deeply peaceful. The water you drink today will eventually return to the atmosphere, become part of a cloud, fall as rain, flow to the ocean, evaporate again, and continue this cycle forever. Nothing is lost. Nothing is wasted. Every molecule of water is conserved, cycling endlessly through its transformations. The same is true of the air you breathe, the oxygen, the nitrogen, the carbon dioxide, all of it cycling through plants and animals and atmosphere, never leaving the system, always present, always available. You are part of these cycles. Your breath contributes to them. Your very existence participates in patterns billions of years old. Weather happens whether we watch it or not. Clouds form over empty oceans. Rain falls on uninhabited forests. Wind blows across deserts where no one walks. The atmosphere continues its work independent of human observation, independent of human need. There's something humbling and comforting about this. The weather doesn't need you, doesn't wait for you, doesn't change for you. It simply is, proceeding according to physical laws, doing what it has always done. You can rest in this knowledge. The weather will take care of itself. The patterns will continue. The cycles will turn. And in this moment, right now, wherever you are held within these patterns. The air around you is part of a global circulation that's been flowing for eons. The moisture in that air is part of a cycle that predates humanity. The temperature you feel is part of a daily rhythm that has never once failed. You are surrounded by reliability, by patterns so deep and so old that they're essentially eternal. The weather holds you. The atmosphere cradles you. The cycles continue, patient and endless. Let yourself surrender now to these rhythms, the sun rising and setting, temperatures cycling through their daily pattern, seasons turning one into the next, water evaporating and condensing and falling and evaporating again, air circulating around the globe, all of it continuing without effort, without thought, ancient patterns repeating, holding you in their flow, nothing for you to do, nothing to control, just rest, just be held, just let the patterns continue. As they always have, as they always will, turning, cycling, breathing, the earth breathing, you breathing, both part of the same ancient rhythm, slower now, slower, until breathing and sleeping become the same one.